This video is on the course of linear algebra, and we introduce a new a subchapter about vector addition and scalar multiplication. So we have two vectors, vector u with components u1, u2, un, and vector v with components v1, v2, vn. Both vectors u and v belong to the Rn vector space. So the addition of two vectors u plus v is defined as u1 plus v1, so we add this one with this one, u2 plus v2, etc. till the last one, un plus vn. So what happens, we saw in the previous video this vector concept in physics. So what is adding from the physics point of view? Adding two vectors. So we have vector u and we have vector v. So v here and u here, this is v. So adding two vectors in physics, this one, the red one, is the diagonal of the parallelogram formed by vectors u and vectors v. So in physics, if you add u plus v, you will get this diagonal of a parallelogram formed by vectors u and v. And now we are going to choose this one. This is not perfect drawing, but it's okay. So now we choose this as the origin, okay, of a coordinate system. So this is a coordinate system for R2. We can say this is X and this is Y, right? This is a coordinate system. And let us say that AB is the endpoint, okay, of vector u. So this is vector u, this one is vector u, and this one is vector v. CD is the endpoint of CD. AB is the endpoint of u. So using geometry, we can show it's really easy. This you can do this. It's really easy. Using geometry, we can show that if we add u plus v, we are going to get to this point where the point a plus c, so this a plus c, and b plus d. Okay, so this will be the endpoint of u plus v. So here we are using geometry, right? But if we add the corresponding components, we can see that u plus v is equal to a plus c, b plus d, according to the definition here, according to the definition of what adding vectors is. Okay, let us see two examples. Let us say we have vector u 1, 2, 3 and vector v 4, 5, 6. What is u plus v? Well, it's really easy, right? It would be 1 plus 4, 2 plus 5, and 3 plus 6. So u plus v would be 5, 7, and 9. Okay, this vector is in R3, and vector u and vector v, they are both in R3 too. Okay, second example, we have vector w 1, 2 and vector m minus 1, 2, 5. Question: what is w plus m? The answer is this is not defined. We cannot do this because W is a vector from R2 and M is a vector from R3. Okay, so the sum is not defined. The sum is not defined since the vectors have different numbers of components. If the vectors are written in a column matrix, so 1, 2, 3 for U and 2, 3, 4 for V, what is U plus V? Well, you just add the components one by one, right? 2 by 3 and 3 by 4. So you simply add the components 1 plus 2, 2 plus 3, 3 plus 4. So 1 plus 2 is 3, 3 plus 2 is 5, 4 plus 3 is 7. If I make any mistake on the calculations, please let me know. Okay,